Hi, welcome to Sagacity Science Hub. Today we'll be looking at Gay-Lussac's law of combining volume. Gay-Lussac's law of combining volume states that when gases react, they do so in volumes which are in simple ratio to one another and to the volume of their product if gaseous, provided that temperature and pressure remain constant. Let me explain. When gases react, note, the reactants must be gases, and when these gases react, they do so in volume. They react by volume, they combine by volume, not by mass. And the volumes of these reactants are in simple ratio. What do I mean by simple ratio? Small whole numbers with no fractions or decimal. The volumes of these reactants are also in simple ratio to the volume of their products, if gaseous, provided that temperature and pressure remain constant. Let's look at this equation for a better understanding. This is a reaction between hydrogen and oxygen. Look at the ratio. These are small whole numbers, 2 ratio 1 ratio 2, small whole numbers. They are not fractions, they are not decimals. So when gases react, they react by volume, which are in simple ratio, which are in small whole numbers, okay, to one another and also to the volume of their products if gaseous, provided that the temperature and pressure remain constant. Let's look at this jam question. 60 cm cube of hydrogen are sparked to 20 cm cube of oxygen at 100 degrees Celsius and 1 atmosphere. The total volume of residual gases is, note, while solving, we have no business with temperature and pressure. So don't let it confuse you. What's the first step? Just listen to the steps and you'll be able to solve these questions carefully. Questions under Gay-Lussac's law of combining volume. What's the first step? Write out the equation for the reaction. This is the reaction between hydrogen and oxygen. You know that hydrogen exists as a diatomic element, that's hydrogen, alongside oxygen to give us water, right? And make sure your equation is balanced. I have 2 atoms of hydrogen here. I have 2 atoms of hydrogen here. Oxygen 2, oxygen here 1. The equation must be balanced, okay? To balance this equation, I have 4 here, 4, oxygen 2, then oxygen here 2, equation balance. Remember I said the first step is to write out the equation for the reaction, which I've just done. Now what's the second step? Write out the mole ratio. What's the mole ratio here? I have 2. What do I have here? 1. And what do I have here? 2. Now note, mole ratio in gas equation can be represented as volume ratio. Okay, and remember Gay-Lussac says that when gases react, they do so in volume. So these mole ratios can also be represented as volume ratio. That's I can write 2 here. Very simple. What's the first step? Write out the equation for the reaction. What's the second step? Write out the mole ratio. And what is the third step? Represent the mole ratio with what? Volume ratio. Then the next step is to write out the given volume. The given volume is from the question. Now let's travel down to the question. What's the given volume of hydrogen? 60 cm cube. Right? Given volume of oxygen? 20 cm cube. For the products, we do not know. Now, note that you have 60 cm cube of hydrogen in the question does not mean that all of it will react. And that you have 20 cm cube of oxygen does not also mean that all of it will react. It is your duty to get the reacting volume. And how do we get the reacting volume? Just pay attention. Reacting volume. How do you get the reacting volume? Let's call this case 1. Write out the volume of the reactants from the equation, the volume of the reactants from the equation. From the equation, this is 2. Hydrogen is 1, right? Good. The second step, write out the given volume of one of the reactants and then represent the given volume of the other reactants with a variable. I'm choosing hydrogen first. which is 60. Then I'll represent the volume of oxygen with a variable, which is x. So when I cross multiply, 60 will be equal to 2x. When I make s subject of formula, 60 divided by 2 to give me 30. I will repeat this step, but in case 2, I'll write out the given volume of oxygen, then represent hydrogen with a variable. Case 2, volume from the equation. Now I'm representing hydrogen with a variable, then I'll write out the given volume of oxygen. So when I make S subject of formula, 40 cm cube. Now note, for oxygen, I got 30 cm cube. Now the question is this: is it possible to have 20 cm cube of oxygen and then the reactive volume will be 30? It is practically impossible, okay? But that of hydrogen, we have 60 cm cube of hydrogen, and then from what we solved, 40 cm cube of hydrogen, which is lesser than the given volume. So we can't use this. Why? Because this is higher than the given volume in the question, okay? When you solve for the reacting volume, if you get a lesser value, you make use of it. Like I said earlier on, that you have 60 cm cube of hydrogen does not mean all of it will react, and that you have 20 cm cube does not mean all of it will react. For you to know if all of it will react, you need to solve for the reacting volume, okay? Which you've done. And I said, if you get a lesser value compared to the one you have in the question, you make use of it. So for 60, for hydrogen, what did we get? 40 cm cube. When we solved for oxygen, we got a higher value, okay, than the given volume. So we'll still make use of 20. It simply means that the 20 cm cube of oxygen will react. Now, how do we get the volume of the product? Very simple. Which of the reacting volume of the reactants did we solve for? We solved for hydrogen, right? Remember, we're not making use of the one we solved for oxygen, and I told you the reason. We solved for hydrogen. So we compare the volume ratio from the equation. 2 of hydrogen will give us 2 of water, right? What will 40 cm cube of hydrogen give us? X. When I cross multiply, 80 will be equal to 2x. That's 40 times 2 will give me 80, will be equal to 2x. When I make S subject of formula, I'll have 8 divided by 2 to give me 40 cm cube. So it simply means that the volume of the product is 40 cm cube. Okay? Now, if 40 cm cube of hydrogen will react, what's the leftover gas? 60 minus 40 to give me 20 cm cube. Here I will have 0 because all of it will react. And for the products, we have what? 40 cm cube. Now let's go back to the question. What's the question? Total volume of residual gases. Gases, not one gas. And how would you get the total volume of residual gases? Volume of the products plus volume of the unreacted gas. Total volume of residual gases, volume of unreacted gas, plus volume of the products. What's volume of unreacted gas? 20 cm cube, right? That's volume of leftover gas, plus 40 cm cube, volume of the product, to give us 60 cm cube. Do we have 60 cm cube in the option? Yes, that's option A. Bye, and see you in my next class.